Hello everyone, thanks for being here. My name is Iuliana Prodan. I'm working at NXP. I'm working at different projects. Actually, the main one is audio subsystem in Linux, Sound Open Firmware, and because Sound Open Firmware is integrated in Zephyr, I'm also working with Zephyr. Today, I'll talk about how we can build a Zephyr-Native audio framework using Sound Open Firmware, or SOF. SOF is already well known in the Linux ecosystem, but the question I'll cover today is how we can make it work just as well in microcontrollers devices, like just running Zephyr without relying on Linux. So by the end of this talk, we'll see how SOF can become the default audio framework for Zephyr, and yeah, let's see how it goes. So this is the roadmap for today. We'll start with an introduction on Sound Open Firmware and how it works. Next, I'll highlight the problem we face, SOF's strong dependency on Linux. Next, we'll discuss our proposal to have Zephyr Linux removed and replaced with Zephyr SOF host. We'll discuss some implementation details regarding how SOF host works, the IPC mechanism used, topology and pipeline creation, and we'll see how audio flows through the system. I'll also show you a proof of concept we've already implemented, and at the end I'll highlight some future work, some directions we have, and we'll draw some conclusions. And also I will leave time for questions. So what is Sound Open Firmware? Sound Open Firmware, it's an open source audio digital signal processing firmware. It runs on DSP, mostly on Hi-Fi 3, Hi-Fi 4, Hi-Fi 5 from Cadence, but it also has support for Cortex-M and Cortex-A cores. It traditionally uses Linux as the SOF host. So Linux is responsible to load the firmware on the DSP, to start the DSP, it implements the IPC mechanism, and also runtime control. SOF has been adopted by multiple companies, by multiple platforms, from Intel, starting with Intel, NXP, AMD, MediaTek, and yeah, the community is big, it's strong, and the source code is completely open. It's on GitHub. You have a link there. Now, here's a view of how Sound Open Firmware is coupled with Linux today. We'll start from the SOF source code. This is compiled with GCC with a free toolchain, but we also have the proprietary Cadence toolchain. With one of these, we obtain an ELF image. This is converted using RImage tool. This is converted to a binary image, which is required by kernel drivers to execute the code and to load the code properly on the DSP. Also, with this RImage, we can sign the image or not. This is optional. Also, during this conversion with RImage, we add some headers and metadata on the ELF file with some firmware configurations, the modules that are used for our firmware, and yeah, this is also required by the DSP and by the SOF driver from Linux. Now, on the topology side, the pipeline is defined in an M file, in an M4 format file. This is converted to a .conf topology file. This is a human-readable pipeline graph, which is structured in a certain format. And next, this is transformed in a topology metadata .tplg file using ALSA tools. So these two files, we have the R image, the firmware image, and the topology file. These are in the rootfs, usually in /lib/firmware on Linux. Now, the Linux is the central part of this system. The Linux kernel, through its soft driver, it's responsible to start the DSP, to load this firmware on the DSP, to configure the pipeline based on the topology file, and to manage the IPC communication between the cores. So yeah, the key takeaway here is that SOF was designed with Linux in mind, and the Linux host is the one that controls the system. Now, let's look from Zephyr angle. SOF itself is modular. Starting with the version 2.0, SOF is using Zephyr as its underlying operating system. Before this was using XtensaOS from Cadence. And from Zephyr, Zephyr actually provides SOF all the RTOS services we have there. We have interrupts, memory management, work queues, etc. And we also have the platform drivers. These were ported to Zephyr by each vendor. So yeah, NXP also ported their drivers. They are in Zephyr right now. And on top of this, SOF comes with the audio components. On the blue side, you see there are a lot of them. We have mixer, equalizer, a lot of effects, and sample rate converters and others. Here I'll make a short break, let's say. If you want to tune SOF, the most important component here is the module adapter. So through this component, this is like a generic component. Through this component, you can link your fancy algorithm that does, I don't know, audio echo cancellation or noise reduction, or your external library that does some extraordinary things. And if you want to do that with SOF, you link it through this component. So it's easy to tune your, your audio system through SOF. Okay, so together SOF running Zephyr makes a complete audio framework, but you have to remember that still relies or assumes that the SOF host, which is on Linux, controls it. So this is what we want to change. Now, the problem in one slide is this dependency on Linux, which does three things, as I've mentioned: loads the firmware, creates the pipeline, and manages the runtime control. But we have many MCUs, like, for example, NXP IMX-RTs, which has a DSP. We have a Cortex-M, but none of them are running Linux. So there's no standard way to have SOF on this kind of MCUs. So this is a big limitation, because SOF cannot be adopted by embedded devices or IoT audio devices. So the challenge we want to fix is, how do we remove Linux from this equation? Now, our proposal is straightforward: to replace the Linux host with a Cortex-M, which runs Zephyr. That means that the Cortex-M with Zephyr will be the SOF host. This will be in charge to do all the things I've mentioned before. Start the DSP, load the firmware, will implement the IPC protocol, and will manage the runtime control. So for example, on a hi-fi, on an RT600, we'll have the Cortex M33 run Zephyr and will act as an SOF host, and the hi-fi 4 DSP will run SOF as before. So that makes SOF useful for IoT audio devices, for, I don't know, like low power speakers or other, I don't know, embedded use cases. So let's go into some details of how we want to implement this. So let's look on the SOF host. In Zephyr, we'll need a soft host driver, and this will be responsible to load the firmware on the DSP and start the DSP actually before loading the firmware on it. We'll implement the SOF IPC protocol on the host side, and we'll define the pipeline, and we'll be sending setup commands to the DSP via IPC. Initially, we are thinking to have the pipeline as static C structures, just to get things working. Later, we can move to maybe device tree or other mechanism. So, in short, Zephyr takes on the same responsibilities as Linux has right now, but in a much lighter and MCU-friendly way. Now, here's the tricky part. The IPC, inter-process communication, is actually the heart of this system. So we have three possible solutions. Raw messaging unit with shared memory. Actually, this first option, it's the simplest to prototype. Each core has its own messaging unit set of registers to send the messages, and shared memory will be used for audio buffers and message payloads. The second option is RPMSG. This is commonly used in MCUs with OpenAmp support. It also relies on shared memory, but it fits into an existing standard. The third option is Zephyr's IPC service. This is a high-level abstraction, and it supports multiple transport layers. And yeah, this is clean, it's extensible, but in case of SOF, might need some adoption in order to fit SOF's IPC format. Anyway, whichever option we choose, we have clear requirements. They all must be checked, let's say. So the message format, it has to follow SOF IPC v3 and v4 format. These are some structure on how the messages are passed between the cores. We'll rely on shared memory for audio buffers and message payload, and also interrupts to notify the other side. So IPC is really the glue code between the Zephyr SOF host and the DSP SOF. Now, for the topology and pipeline management, a pipeline, it's a graph of audio components. You can think of them as a chain of, let's say, a buffer, a mixer, then again a buffer, you'll have an equalizer, and other effects. So in Linux, to define the pipeline, we use this external topology file. But in Zephyr, we are thinking to have a static C structure, and the flow will be like the Zephyr host will send some setup commands to the DSP via IPC. The DSP will start creating the pipeline internally, and when the pipeline is ready, the SOF host will trigger playback. So the core idea is the same as in Linux, but the configuration source, it's different. If it's dynamic in Linux, in Zephyr will be static, but I believe that's a practical first step for us right now. Okay, this is an example of how a simple playback will work through the system. So the SOF host from Zephyr will parse the WAV file, will extract the WAV header and gets the audio format like sample rate, bit depth, channels. These parameters will be sent via IPC through the to the DSP. Next, the SOF host will start streaming PCM data into the shared memory, and the DSP will start processing the data from there. Yeah, the host is also responsible for handling buffer underrun and overrun, and yeah, it must make sure that the stream is smooth. And on the DSP side, after processing the data, we'll output that audio through the codec. So the flow mirrors the same thing as in Linux, but everything relies on the SOF host from Zephyr. Now, yeah, we have implemented the proof of concept. You have here the links to my colleague Vít Stanicev's work he did on his bachelor degree project. This is done on RT600. The Cortex M33 runs Zephyr and acts as an SOF host. And on Hi-Fi 4 DSP, we run yeah, SOF as usual, because we also run on MPUs. So for the IPC, we use the raw messaging unit with share memory. As audio source, we use the static PCM data array, which is pushed through a static pipeline. And yeah, actually this validates that SOF and Zephyr can work together without Linux. And I believe this is a very important milestone because it shows that this concept is not just theoretical, but practical. But yeah, there's much more work to do. That was a proof of concept. So the first steps we want to take from now on is to rework this code and make a PR with this proof of concept. But yeah, we need to rework the IPC part. We want to move from the static C structure for pipelines to device tree or maybe a domain-specific language. That will be easier to maintain. A shell command line in Zephyr will allow developers to create and control pipelines at runtime. We also want to add kconfig options to be able to select a pipeline at build time. Yeah, that will be nice. Yeah, so as you can see, the roadmap is quite clear. So yeah, there are opportunities for community contribution, so feel free to help. And yeah, some key points, some conclusions. So by decoupling SOF from Linux and rely on Zephyr, I think this will bring SOF closer to microcontrollers. So we'll make SOF practical for MCUs and IoT class devices. This makes, in my opinion, this makes SOF the standard audio backend for Zephyr, so developers don't need to reinvent the wheel for audio in Zephyr. If we remove, actually, by removing the dependency on Linux tools, will make the development easier and portable. And yeah, I believe we also improve portability and the power efficiency, which are critical in embedded devices. Yeah, so in my opinion, the conclusion is clear. This makes SOF flexible and scalable audio framework for Zephyr. And that's it from me. Thank you. So if you have any questions, yes.
Do you see some use cases where SOF and the SOF host would run on the same core?
Yeah, I think that was our first proposal, to have everything run only on the DSP. This is possible, of course, but I think we'll miss some of other features. Like you'll have a static pipeline, the DSP must be started before everything, or maybe the M core will just start the DSP and then we'll do nothing. You'll have, in my opinion, you'll have more hard-coded pipeline just running on the DSP. Having also the M core, I think, will allow some not just communication, but also you will be able to change some pipelines, to change some information with the other core. But yeah, that's possible, and I think it's easier. It will be easier to have that solution. But yeah. Okay, I think you in the back were the person.
You mentioned opening upstream PRs. Is there somewhere we can check out the current state of things to play with?
Yeah, I've put the links there. There are two links with his documentation, with Vit documentation, and also the source code. It's not yeah, it's split in patches and everything, but yeah, you'll have to dig a bit more. Sure.
To follow up on the question there, so you mentioned running on the DSP alone, but conversely, would it be possible to run as well on the Cortex-M core, on powerful ones? Maybe we have some acceleration for simple pipelines?
Yeah, it's possible because the SOF already has support for Cortex-M, as I mentioned, and also for Cortex-A. So if we have an MCU without a DSP, that's also possible to run everything on an M core, or our exactly proposal to have an M core for SOF host and another M core for just SOF. So yeah, it's possible. Yes.
So apparently this is the second time you use SOF from, well, it's a second implementation from a host point of view, talking to an SOF core. Have you thought about stabilizing the IPC and documenting it? Is it documented? Could you share that? And would that be a first step in getting something useful to others?
IPC, I think it's already documented in SOF documentation. SOF, in my opinion, has a very good documentation. I don't remember the site is something, the SOF project or something. Yeah, it's documented. It's not in the Linux, it's in the SOF project.
Would you expect third-party implementations then? Or do you allow yourself to break the IPC tomorrow and that would cause issues?
No, we don't want to break. That's why we have three possible solutions for the IPC, and I believe the IPC service API from Zephyr will be the best solution. I think Intel already had a proposal for an IPC service in Zephyr for the communication between the cores. Yeah, so it will be in Zephyr for sure. The community will not let us break some compatibility or have a not proprietary, I don't know, we want to have a generic IPC, not something just for SOF. So yeah, I don't think we don't want to break the compatibility, and also we don't want to make too many changes in SOF. That's why if we add an IPC service in Zephyr for SOF, we want to keep the SOF IPC as is. Yeah. Other questions? No, most of the changes will be in Zephyr. Yeah, we want SOF to work as before. So we would like to have SOF work, because right now, for example, us, NXP, we'd like to have SOF running on RTs, on Irotmix RTs. So we want to keep SOF also work with Linux. So we don't want to change the SOF core. Most changes are in SOF. For the proof of concept, there were also some changes in SOF for the pipeline, but as I said, it is a proof of concept. We have to rework some stuff in order to upstream everything.
Have you done Zephyr? That's on a private tree from Git. I mean, it's not pushed in an official Zephyr tree to pull request.
Yeah,
Julia has a request for comment proposal about this in Zephyr as a pull request or as a
yeah, there's an RFC in Zephyr open. I'm sorry I didn't put the link here, but I think if you look on issues and RFC in Zephyr list, there you will see this proposal on. To be honest, I forget how I called it, but it's something with SOF and audio framework in Zephyr or something like that. Yes. No, we cannot do that. So if you're starting SOF on the DSP, it will be just SOF. We're not having other threads to run something else. It will be just SOF. Yeah, maybe you can think of a use case, but right now, no, we don't have that.
Thinking about use cases, can you give some more context into what's your goal? So you talked about your own hardware, RT600, I think. What kind of projects do you expect? What kind of processing on the DSPs can you expect? Do you have any commercial projects in mind that are coming in, that are using SOF on Zephyr? Can you talk about
Well, I'm a software engineer. I have no ideas of the project or marketing and stuff like that. But in the past years, being in conferences, we got a lot of these questions like, I would like to have SOF also on MCU because I have a DSP there. I have no audio solution. So how would you do that? SOF runs right now on MPUs, so yeah, it relies on Linux. So yeah, that's why we think of this solution. But I don't have in mind any product. I have no marketing, I don't know. Yeah, but there are products like low power speakers, as I mentioned, or I don't know, some audio devices, small audio devices. I think there are, but not good at that.